Hi ladies and gentlemen, this is Ms. Skokin. We are in section 10.2 and we're going to be taking another look at hypothesis testing. Today our research question is there a difference in the number of chocolate chips in Chips Ahoy cookies versus the number of chocolate chips in Meyer brand cookies? Each pair of students will count the number of chocolate chips in one Chips Ahoy cookie and one Meyer Chipsters cookie. Due to the factory's processes, we can assume the population distributions of numbers of chips are approximately normal and that the samples are random. After looking through the chocolate chip cookie and counting the number of chips, we found that in our Chips Ahoy cookie, we had 17 chocolate chips. We notice in the Meyer Chipsters, we had 15 chocolate chips in the cookie. That was for one sample. Since everyone in the class had an opportunity to test the chocolate chip cookies, we're going to find the mean number of chocolate chips for each type of cookie, the standard deviation of the number of chips, and the difference. So we start with Chips Ahoy. Our mean value ended up being 15.8 with a standard deviation of 4.2. The Meyer's Chipsters, we ended up having a mean of 15.1 with a standard deviation of 6.3. The difference between x1 and x2, x1 bar and x2 bar is 0.7. And you may remember when we do the standard deviation that of combined random variables, what we have to do is that Pythagorean theorem of statistics. Question number 3 says, if we repeated this process many times and created a dot plot, we would have the approximate sampling distribution of x1 bar minus x2 bar. And the shape would be approximately normal, and we know this because the population of the distributions of chocolate chip cookies is approximately normal. The center of the sampling distribution is going to be mu sub x1 bar minus x2 bar, and that's going to be mu sub 1 minus mu sub 2. And the spread we already talked about. Number 4 asks us about conditions. Have the conditions for constructing a confidence interval been met? And the answer is yes, they have been met. Number 5 says construct a 95% confidence interval for the true difference in the mean number of chocolate chip cookies in Chips Ahoy and Meyer Chipsters. So this is going to look just like what we've been doing for proportions, where we have our point estimate plus or minus the margin of error. Then we get a little bit more specific, and that means we're going to have an x1 bar minus x2 bar, our difference in means, plus or minus, and if you remember we talked about this a long time ago, instead of z star we're going to use t star, and then we're going to have the standard error, which is going to be s1 squared over n1 plus s2 squared over n2 and the square root of that. So that right hand side of the plus or minus is going to give us our margin of error. Now we're going to see that if when we perform this in our calculator, we're going to end up with a much smaller degrees of freedom. But for right now, we're going to write down that the conservative degrees of freedom is equal to the smaller of the two n's minus 1. And that means we're going to take a look at the two sample sizes. Whichever sample size is smaller, n1 or n2, we're going to subtract 1 from that. That will be our conservative degrees of freedom. Number 6 asks us, do we have evidence that there is a difference in the average number of chocolate chips in a Chips Ahoy and a Meyer Chipsters cookie? And the answer to this question is all about what we end up with in the interval. So let's just refresh our memories on what we could see. We either end up with a lower bound and an upper bound that are negative, and that means that the Meyer Chipsters cookies have more chocolate chips. We could have a positive going to a positive for the lower bound and upper bound. That means the Chips Ahoy cookies have more chocolate chips. And we could have a negative to a positive, which means 0 is part of our interval, and that means that there's no difference between the two cookies, the amount of chocolate chips in each, or the mean number of chocolate chips in each. We're done with this page, and that means it's time to write the important information or important ideas in our box. Let's start with the conditions for inference for means. If conditions for inference are met, we are going to construct a 2-sample t interval for mu1 minus mu2. The first condition that we need to meet is random. Both of our groups need to come from random samples or a randomized experiment. The next condition is going to be independence, and independence can mean one of two things. It's either going to be the 10% rule, or we want each of the experiments, each of the groups, the behavior to be independent from every other member of the group. Last of all, we need the normal condition to be met, and normal can be met in a few different ways. One of the things that could happen is we could have the population being normal. That's the parent population. The next thing that could happen is we could meet that central limit theorem that we talked about a really long time ago. I know it feels like that anyway. And the third way is if we have no strong skew or outliers in the graph of the sample. When we're putting together our confidence interval, one of the things that we need to know is the degrees of freedom. Remember that we're going to be using a t star for our critical value. And our general formula is going to be point estimate plus or minus margin of error. That's going to go to a more specific formula of x1 bar minus x2 bar plus or minus our t star times the standard error, which is s1 squared over n1 plus s2 squared over n2. So when it comes to the shape of our sampling distribution, the center is going to be located at mu sub x1 bar minus x2 bar, which is mu1 minus mu2, and the spread or variability is going to be the standard error of x bar 1 minus x2 bar, which is equal to, and I already wrote it up above, but here we go again. And now we're ready to go over the check your understanding. Mr. Wilcox's class performed an experiment to investigate whether drinking a caffeinated beverage would increase pulse rates. 20 students in the class volunteered to take part in the experiment. All of the students measured their initial pulse rates in beats per minute. Then Mr. Wilcox randomly assigned the students into 2 groups of 10. Each student in the first group drank 12 ounces of cola with caffeine. Each student in the second group drank 12 ounces of caffeine-free cola. All students then measured their pulse rates again. The table displays the change in pulse rates for the students in both groups. And you can see we're given the individual pulse rates and the mean of each of the 2 groups. We're going to construct and interpret a 95% confidence interval for the difference in the true mean change in pulse rate for subjects like these who drink caffeine versus who drink no caffeine. And I'm going to give you a little hint. You're going to be turning off the video in a minute and you're going to be working through this. But I am going to recommend, before I instruct you to turn the video off, to find the standard deviation of both of these groups. If you remember, what you are going to do is put these values into your calculator, and then you're going to run one variable statistics. That'll give you the mean and the standard deviation. You want the standard deviation that's S, because these are samples, not the full population of sigma. All right, so you're going to turn the video back I'm sorry, turn the video off now, and you're going to turn it back on when you're ready to check your final answer of the state plan do conclude format. See you back in a few minutes. Okay, hopefully you didn't have any difficulty with that, and you were able to not only go through the process, state plan do conclude, but end up with the same confidence interval. In class, let's figure out how to do this in the calculator so that we can check the interval that we got. Obviously, we still have to show all of this work, this beautiful work, so the way that we're going to be answering these questions on our free responses on the exam is fully fleshed out like this. But again, in the calculator, we can at least check and make sure that we got the correct interval. Okie dokie, that's it for now, and I'll see you in class.